All right, so let's go over some specifics about significance tests for means, and then we're going to work. The next video is going to be the actual example. Okay, so when you're conducting a test for a mean, okay, and this is going to be a one sample t-test. Again, t-test because we're using the t-statistic instead of the z. Okay, and the test statistic is going to be x bar minus mu 0 over s divided by the square root of n. Okay. All right. And that's, again, when we're dealing with t. Okay. So t is going to always have that n minus 1 degrees of freedom. Okay. And x bar and s come from our sample data. So again, we're going to have the mean from our sample and our standard deviation from the sample. And so because of that, that s over square root of n becomes our standard error instead of standard deviation. Okay. All right. But if we do know the population of, or the population standard deviation, which, like I said last time, you rarely ever have that, then we get to use a one sample z-test instead. So z-test, okay? And that's gonna use, it looks almost exactly the same, except we're finding a z and we're using the population standard deviation instead, okay? And then once we have our t-statistic, of course, we will end up with a, couple of t's like this. We'll have a negative t and a positive t, okay? And we're going to use the we can use our calculator to find it. We can use TCDF to help us find that. Okay, we'll talk about that in just a moment. Okay, but of course, it wouldn't be complete without a rundown of our different conditions. So we need a random sample. So random sample or random assignment, depending on our situation. We got to make sure that we pass the independent condition, the 10% condition, so we got to be less than 10% of our population. And then normals where things get a little bit iffy. Okay, so if n is greater than or equal to 30, then the central limit theorem tells us we're going to be normal. But then if n is less than 30, we have a couple options. Okay, we might be told the population is approximately normal, or we might have to graph our sample data to make sure there's no outliers or strong skewness. All right, so that's going to be it. All right.